if I wanted to know the angle from here to here in this direction, right? I could take 90 degrees plus 90 degrees plus 90 degrees is 270 degrees. Okay, so very easy to add degrees, right? We can all do that, no problem. But what happens if the angle that we're trying to solve, or the angle that's given to us, isn't just in degrees? What if it's a smaller value? You know, in the imperial measuring system, when we're measuring in inches and something is greater than 1 inch but less than 2 inches, let's say is 1.475, so if it's not a whole number, there's a decimal value that we can attach, right? A fractional part of a whole number. Well, degrees can be broken up into fractional parts. But unlike imperial units and metric units, we don't say 1.4 inches or 1.2 millimeters. The fractional component of degrees, you can say 1.3 degrees, which is fine in the when we're talking about metric values, because metric and imperial systems both have expectations when writing angular measurements. So in the imperial system, I wouldn't write 1.3 degrees. In the metric system, I would, right? I could say 1.3 degrees. But this decimal piece, this fractional piece of a degree, can also be expressed in its own terms, minutes. Okay, so I can take this 1.3 degrees and I can express it as 1 degree and X number of minutes once I show you how to do that. At what point is a degree expressed as a fractional component? So let's imagine that 360 degree circle. Let's just take the top part. Let's just take one piece of it. Okay, so we take that circle and we divide it up into 360 pieces. Okay, so we have that full circle. We know there's 360 degrees in that circle. Let's take 1 degree out and upsize it here so we can look at it, okay? So if we want to understand fractional degrees, we can take 1 degree and we can break it down, right? I won't draw all the lines, but basically if I break this degree into 60 pieces, 60 equal pieces, then what I get is 1 degree is equal to 60 minutes. Okay? 1 degree is equal to 60 minutes. So I can take 1 degree and I can slice it into 60 even pieces, and those 60 pieces will equal 1 degree. So just like this is why we start with fractions, right? We start with fractions so that we can understand that even when it comes to measuring in degrees, we can take a whole number or a whole degree and we can break it into several pieces or a fraction of a degree. So before we were talking about 1.3 degrees, right? We can have 15.75 degrees. How does that translate into minutes? So if we know that there's 60 degrees, or sorry, 60 minutes in 1 degree, we could take a number like, let's say, let's start something easy, 1.5 degrees. Okay, we take 1.5 degrees. Well, what is this in degrees and minutes? So the first thing we do is we get rid of the 1, right? We already know it's 1 degree. This is a fraction of a degree, so the whole degrees are not going to change here. But I want to take this 0.5 and I want to convert it into minutes. So this is our multiplier, guys. Because there are 60 minutes in 1 degree, that becomes our multiplier. So if I want to know what 0.5 is in minutes, then I take that 0.5 and I multiply it by 60, right? So 0.5 times 60 is 30, right? So what I can do here is I can change this 0.5 to 30 minutes. Okay, so whatever your decimal is, you can convert that decimal to minutes by multiplying it by 60. And the reasoning behind it is right here. 1 degree is equal to 60 minutes. So 60 is the multiplier. It is the total number of pieces that are available to us. Remember in fractions? So if I only have 0.5 degrees, if I multiply that by my multiplier by 60, it will tell me how many minutes. All right, so let's just try another one of a different value just to make sure that we get this, right? So let's say we have an angle of 25 degrees, or 25.875 degrees. Okay, so 25.875 degrees. Well, the first thing that we got to do is we got to write down the whole degrees. So we'll bring the 25 down. Okay, 25 degrees. Now our fractional degrees is 0.875. So we take this 0.875 in our calculator and you multiply that by 60, right? Because 60 is our multiplier. So 0.875 times 60 is equal to 52.5 minutes. So now I had a decimal degree here. Now I have whole degrees and a decimal minute, right? So now any instructions that we get in our assignments will tell us, it may say round to the nearest whole minute. All right, so if we're told to round to the nearest whole minute, remember that decimal place, that 5 tells you what to do to the 2, right? So if this was round to the nearest whole minute, it would say 25 degrees, 53 minutes, right? But what if I need to know the degrees, minutes, and seconds? Well, what's a second? So let's look back at this example again, okay? Imagine instead of this being 1 degree of a circle, imagine now that it's 1 minute of 1 degree. Okay, so now we've taken 1 minute out of those. These are 60 minutes. Now I'm going to take one of these minutes and I'm going to redraw it here. And I'm going to divide it up into 60 pieces. And now that's our seconds, right? So 1 minute is equal to 60 seconds. So now I can apply that to this answer, this 25 degrees, 52.5 minutes. I can write my 25 degrees again, and I can write my whole minutes, 52 minutes, and then I take my 0.5 minutes and I multiply it by 60. Because again, 60 is the multiplier because there are 60 seconds in 1 minute. So 0.5 times 60 is 30 seconds. So a decimal degree can be converted into degrees and minutes, and degrees, minutes, and seconds. But notice it takes 2 steps here, right? I multiplied this decimal degree by 60 to give me my minutes, but there was also a remainder in the minutes. There was a decimal minute. I can take that remainder and multiply it by 60, and it will give me the seconds. Now, this doesn't always work out evenly, right? We don't always get a whole second. This may, depending on what our question was, this could have been 30.2 seconds, right? But we would round always. If you think about the accuracy of this. Now, imagine we have that circle, right? And now there's a call out on a print. It doesn't matter what course you're in, right? So there's a call out on a print that says this angle has to be cut at 30 degrees and 25 minutes. Well, think about that accuracy. And not just you construction guys, you may look at that and say, are you kidding me? If I'm plus or minus 2 degrees, I'm laughing, right? Which is fine for a lot of applications. And as machinists, we're like, well, if we're with it plus or minus half a degree, we're good because we can do that. But now when you start thinking about, accuracy to 1 minute or seconds, you got to start thinking about how precise that measurement is, the requirement, and how do you measure something so precise. So the reality is in the construction trade, you're never going to have to worry about actually achieving this. And if you are, construction's come a long, long way. In machining, it is so rare, so very rare that we have to measure to seconds or develop products to an angular tolerance in seconds. Now, I'm not saying it never happens. It does happen from time to time, and we have special measuring equipment for that. But you have to realize that any dimension in any trade that is called out on a print, however you measure that dimension, if it was possible for you to go into, say, a machine shop, create this angle and measure it, remember that that piece of measuring equipment that you're using to measure this dimension had to be measured with another piece of measuring equipment for accuracy 10 times more accurate than what you're using. And that's the 10 times rule in machining. So you really got to think about the practicality of the application part of this, right? So for us and our purposes, we just need to understand how to convert, right? We need to be able to take geometric values, geometric problems, and solve them